Hi dear students, in our last session we were discussing about the introduction of polynomials. Hope you understood the terms of polynomials, right? So today we are going into the exercise number 2.1. Here goes the first questions before you. Which of the following polynomials are a polynomial in one variable? What does it mean by polynomial in one variable? Polynomial in one variable means there should be only a single variable, means the given polynomial should be in x, or it should be in y only, or it should be in z only. There should be only a single variable, and we are going to check. Here you can see there are 5 questions given before you. The very first question number 1, 4x square minus 3x plus 7. 4x square minus 3x plus 7. Is this a polynomial? Yes, it is a polynomial. Why? Because let us check the powers of each term. While checking the powers of each term, 4x square, the power is a whole number. X square means 2, it's a whole number. What is the second term? 3x is also in that one. X, you can see the power of x is 1. So we can say this given statement or the given algebraic expression is a polynomial. It's a polynomial, right? That much we understood. Now what is our question actually? We have to find whether this is in a one variable. Is it in one variable? That means, is there any other variable? Now you can see x. Is there any other variable rather than x? No. Other than x, there is no other variable. You can see it is only in x. So we can say yes, this is a polynomial in one variable. It's a one variable polynomial. Okay. Let us come to the second question and let us check the same. Question number 2. Y square plus root 2. Y square plus root 2. It's a polynomial in y, right? Y square plus root 2. It's a polynomial in y, and there is only a single variable, and that is y itself. So we can say this also comes under the category of a single variable polynomial, a polynomial with single variable. Check out the third question. 3 root t plus t root 2. 3 root t. Root t. What does it mean by root t? Root t means t raised to 1 by 2. We have studied in our 8th class, right? Means root of t means t raised to 1 by 2. If it is a cube root of t, we will say t raised to 1 by 3. Here it is a square root, that's why we can say it is t raised to 1 by 2. So anyhow, there is only a single variable, that is t here. That is t. It's a single variable. But our question is this a polynomial? Is this algebraic identity or the given statement, is it satisfying the conditions of a polynomial? What was the condition of a polynomial? The power should be a whole number, or the exponent should be a whole number. See here, the first term itself, t raised to 1 by 2. T raised to 1 by 2. 1 by 2. Is it a whole number? What is a whole number? Whole number means all the natural numbers, all the counting numbers along with 0 is what we call whole number. That means 0, 1, 2, 3, 4, 5, 6, 7. Those numbers are what we call whole numbers. Is it a whole number now? No, it's a fractional number, right? It's a fraction. So we can say even though there is a single variable, this is not a polynomial. So we will say this is not a polynomial. Okay, let us check out the next question. Question number 4. Y plus 2 by y. Y, that's the first term. 2 by y, second term. Check out the first term. Y, yeah, it's a single variable. In the second term also 2 by y. It's only of a single variable y. Okay, now let us again check whether this is a polynomial. The first term, okay, it's nothing to worry about the first term because it's just y is given. It's okay. What about the second term? It is 2 by y. Means 2 multiplied by 1 by y. That is what we call 2 by y, right? 2 into 1 by y is what we called 2 by y. So 1 by y, we can write it as y raised to the power minus 1. In our 8th class we studied that one, right? In the very first chapter we studied about that one. 1 by y can be written as y raised to minus 1. So the power of y in the second term came as negative. That means it's not a whole number. So what can we conclude? We will conclude that this given algebraic statement is not a polynomial. It's not a polynomial. Last question. X raised to 10 plus y raised to 3 plus t raised to 50. X raised to 10 plus y cube plus t raised to the power 50. Let us check whether this is a polynomial. Yes, it is, because how to check a polynomial? Right now we discussed it. How was it? Check out the powers of each term. and each term, the power of each term should be a whole number. Here you can see in the first term the power is how much it is? 10. In the second term the power is 3. In the third term the power is 50. All things are whole numbers, so it's okay. It's a polynomial. But as per our question, what was our question? Whether it is of a single variable. Is it a single variable polynomial? No. There are 3 variables, x, y and t. So even though it is a polynomial, we will say that it doesn't come under our category, because we need to check whether it is of a single variable. So sadly we have to say that here it is not of a single variable. Even though it is a polynomial, it is not of a single variable. Clear? Let us go to the main question number 2. Write the coefficients of x squared in each of the following terms. That means here some polynomials are given. So in these polynomials we have to write the coefficients of x squared. Before that, let me ask you, what does it mean by coefficient? Especially it is given coefficient of x square. Coefficient of x square. So you have to find the coefficient of a particular or a typical term. What does it mean? It means that the term coefficient means the constant number which is lying in front of a variable. The number which lies in front of the variable is what we call a coefficient. Coefficient. So how will we check? Here specifically it is mentioned that you have to find the coefficient of x square. X square, the square of x. You have to find the coefficient of x square. So let us go to the first question. I will tell you how to find this. So let us check out the very first question. 2 plus x square plus x. 2 plus x square plus x. Focus your, there are 3 terms, right? Here you can see 2 is the first term, x square is the second term, x is the third term. Your eyes should focus on the term x square. Focus your eyes on x square only, because we want to find the coefficient of x square, not the coefficient of x. Even though here you can see an x is there, our question is not to find the coefficient of x. Our question is to find the coefficient of x square. So you have to focus on the term x square only. I repeat, you have to focus on the term x square only. Now focus on x square. Is there any number lying in front of x square? No. Actually nothing is written. If nothing is written, it is 1. Keep in your mind, if nothing is written, it is 1. So we will say the coefficient of x square is 1. Wait, let us check out what the sign will be. In front of x square, what is the sign? It is plus. So definitely it is plus 1. So the coefficient of x square is plus 1. As it is plus 1, there is no need to mention plus sign there. Just simply write 1. If you are simply writing a number 1 or 2 or 3 or 4 like that, it means that it is plus 1 or it is plus 2 or it is plus 3. For positive numbers, there is no need to again and again represent it as plus 1, plus 2. The number itself, it represents as a positive number. If it is a negative number, then specifically you have to mention it as minus 2, minus 3 like that. So here, as it is a positive number already, we will simply write the coefficient of x square is 1. Is it clear? Coming to the next question, question number 2. 2 minus x square plus x cube. 2 minus x square plus x cube. So there are 3 terms again. The first term is 2. The second term is minus x square. The third term is plus x cube. So as I told you earlier, again focus your eyes on x square. X square, that is the term which we needed. So let us check out x square. In front of x square, is there any number? No. There is no number, right? So if there is nothing number specified there, we will take it as 1. Now let us check out the sign. Just check here. In front of x square, you can see there is a minus sign. So we will say the coefficient of x square in this polynomial is minus 1. Is that clear? Now coming to the next question. Pi by 2 x square plus x. Fix your eyes on x square. What is the term in front of x square? What is the number in front of x square? It is pi by 2. So we will say the coefficient of pi by 2 x square plus x is, what is it? Pi by 2. Clear? One more question from that same category. Root 2x minus 1. Root 2x minus 1. So here we will say that root 2 is the coefficient of it's the coefficient of x, right? It's the coefficient of x. It's not the coefficient of x square. What was our question? What did I told you? Fix your eyes on the term x square. My question is, in this question, is there any term of x square? No, because you can see it is root 2x, not x square. The term x square is missing. That means there is no term, that means there is no coefficient. Okay, don't write it as root 2. That's why I told initially. Don't write it as x square root 2 because it is the coefficient of x. Actually, we want the coefficient of x square, and here the term is missing. So we will say the coefficient of x square in root 2x minus 1 is 0 because there is no term. Hope you understood. This is the way how to understand what the coefficient of the given term is. If they are asking to find the coefficient of x cube, what is the coefficient of x cube in the given following question, then fix your eyes on x cube term. If they are asking what is the coefficient of x raised to 100, search out the term x raised to 100 and find it, and find the number exactly which is lying in front of x raised to 100. That's the way how to find the coefficient of any given term. Hope you understood. Let's go to the question number 3. Give one example of a binomial of degree 35, a binomial of degree 35 and monomial of degree 100. What does it mean by binomial and what does it mean by monomial? First of all, we have to come to that one. Then only we will go to the part of degree. Okay. So what is the first thing? You have to find a binomial with the degree 35. What does it mean by binomial? Binomial means a polynomial with two terms. Two terms. Simply say an example. X plus 2. A simple binomial. Right? X plus 2. Two terms. Now, you got a binomial. We are going to write it x plus 2. You got a binomial. Now my question is, what about the degree? You have to bring it to the degree of 35 because the question, it mentions that the degree should be 35. How can you find the degree of a given polynomial? Find the highest power. So here what is the power of this given polynomial x plus 2? It is 1 because you can see on the top end of x nothing is written. That means it is the linear polynomial. It's of degree 1. It's of degree 1. We want to change to degree of 35. What do we have to do? It's nothing, just simple. Just place 35 on the top of x so that it will become x raised to 35 plus 2. That's all, because it's a binomial. Two terms are there, and now the power became 35. So we can say this is a binomial with the degree 35. So anything, you can write x or you can write y, it doesn't matter. You can simply take x plus 37, x plus 93, anything. It should be a binomial, that's all. That's the condition. What is the second question along with that one? You have to find a monomial with degree 100. A monomial, simply say a monomial, x. A simple monomial, x, right? What about the degree of x? It is 1. What we have to make? We have to make it to 100. So write it. Tell me, how we will write? X raised to the power 100. X raised to the power 100. Now the degree of this monomial became 100. It's a monomial and the degree became 100. That's it. Next one, main question number 4. Now we are going to write the degree of each of the following polynomials. Here the polynomials will be given and you have to mention the degree. How to mention the degree? Check out each term of the given polynomial and then find what is the highest power given there. And that highest power is what we call the degree of the polynomial. So let's go with the first question. 5x cube plus 4x square plus 7x. 5x cube, you can see here x cube, x square, x. I'm just checking on the variable part. There is nothing to deal with the constant part, so I'm just neglecting those things. Just to focus your eyes on the variable part. X cube, x square and x. X cube means the highest power is 3. X square means the highest power is 2. X means the power is 1. Which one is bigger? X cube is bigger. So we will say this is a third degree polynomial, or the degree of this polynomial is 3. Let me ask you, what will we call a third degree polynomial in general? We will call it as a cubic polynomial. So in simple words we can say this is a cubic polynomial. Now let us check out the second question. 4 minus y square. So here fix your eyes on the term y, because that is the variable given here. Y square, that is the only variable. So y square means y raised to the power 2. So we can say the degree of this polynomial will be 2, right? And what does it mean? It means that this is a quadratic polynomial because the degree is 2. Clear? Third question. 5t minus root 7. 5t. So here fix your eyes on 5t, t only on the power, only on the variable t. What is the power of t? It is 1. So we will say the degree of this polynomial is 1. And as the degree of the polynomial is, what is it called in general? It is called as linear polynomial. It's called as linear polynomial. Now one more, 3. 3, it's just a number. Up to these 3 questions I told you, fix your eyes on the variable, fix your eyes on the variable, fix your. What about this one? Is there any variable? Can you see any variable there? No, it's just 3. It's just 3. If there is no variable, how can you fix your eyes on that variable and say the power? Don't think that it is a wrong question, okay? Don't think that it is out of question, it is something else, and unfortunately they forgot to put the x. Don't think like that. I will tell you. 3 can be written as 3 into 1. Is that clear? 3 can be written as 3 into 1. And 1 can be written as x raised to 0. We already studied in our 8th class these things. Any number raised to the power 0, a raised to 0 is equal to 1. Just recollect that one, right? Any variable raised to the power 0 is 1. So x raised to 0, it is 1. So 3 into 1, that is 3. So instead of 1, if I am substituting that with the x raised to 0, I can say that it is actually, it's not just 3. In the algebraic way, when we are thinking it in the algebraic way, we can say it is a 3x raised to 0. 3x raised to 0. So what is the power? It is 0. So what is the degree? The degree is 0. The degree is 0 means don't say that there is no degree. That is not the meaning of that one, okay? Don't say that the degree is 0. That means there is no degree. It's not like that. It's not like that. The degree is 0 means the degree of the polynomial is actually 0, the number itself. So keep this in your mind. Even if it is 3, 4, 99, 1000, 10 lakh, 90 lakhs, 1 crore, whatever it is. If it is a number, then the degree of that number will be definitely 0. Clear? Forget not. And this is what we call constant polynomial, right? It's a constant number. It's called constant polynomial. We discussed this in our introduction part, right? Okay. So that's all from there. Let us go to the main question number 5. Classify the following as linear, quadratic and cubic polynomials. Linear polynomial, quadratic polynomial, cubic polynomial. See, when you are about to see, when you are reading the question, automatically that should come into your mind. Means what are we going to do with? What should we deal with? Which tool is required to do this one? You must understand that one. If the teacher came to your class and tell he or she is the teacher is giving you an instruction, take out your notebooks, you just take the notebook and place it over your desk. Then she said something, okay, come on, now today we are going with some dictations, and I will give you some dictation, and you some words, I will just give you some words and you have to write them. So automatically your hand will search for a pen, isn't it? Because you know, if you want to write something on the paper, you need a pen or you need a pencil. So you know what you need, and automatically your hand will go in search of that one when you are hearing an instruction, right? If you know what is a tomato, if you know the color of a tomato, if you know the shape of a tomato, and your mommy told you to go to bazaar and get some tomatoes, automatically that figure is there when you're going to bazaar. And if you're seeing the tomatoes, if you're seeing the vegetable store there, from that one you can understand, oh, there is tomato, so I will go and I will fetch some tomato from there. Just understand, just imagine, like, if you don't know the shape of a tomato, you don't know the color of a tomato, you don't know exactly what it is, then how will you buy it? Even if you are standing in front of a tomato store itself, you will never understand that that is the thing which you want. So when you are hearing an instruction, something should come inside your mind. We have to do this one. So here, while hearing that, you have to classify them as linear, quadratic and cubic polynomial. So first of all, you have to get that idea what linear polynomial is, what quadratic polynomial look like, and how exactly the cubic polynomial look like. When you're seeing a polynomial, how can you understand whether it is cubic? That should come into your mind. Then things will be very easy for you. So let me remind, what is linear polynomial? A polynomial whose degree is 1. What is cubic polynomial? A polynomial whose degree is 3. What is quadratic polynomial? A polynomial whose degree is 2. Now how will you understand what the degree of a given polynomial is? Just by seeing each term and checking the powers of each term. What will be the highest power? That is its degree. That is what its degree is. So now let's get into the question. Very fast you will understand like this. Come on. The first question, x square plus x. There are two terms. First one is x square, second one is x. Means the power of the first term is x square. It is 2. The power of the second term is 1 because if nothing is written means it is 1. Which is bigger one, 2 or 1? 2 is the bigger one. So we will say the degree of this polynomial is 2. Now tell me, what about this one? If the degree is 2, what does it mean? In which category does it come? Is it linear? Is it quadratic? Or is it cubic? As the degree is 2, we will say it comes under quadratic polynomial. Right. So this is quadratic polynomial. Question number 2. X minus x cube. X, first term. Second term, minus x cube. X means the power is 1. X cube means the power is 3. So the highest power is 3. So we can say that as the highest power is 3, the degree of this given polynomial is 3 itself. So if the degree is 3, in which category this question comes? Degree is 3 means it comes under cubic polynomial. So we will say this is a cubic polynomial. The final question. Y plus y square plus 4. Y plus y square plus 4. Focus your eyes only on the variable part. Y square. Y raised to 1. That's what we call y, right? The power is 1. Y square, the power is 2. So the biggest power is 2. This will be a cubic polynomial. Is it? No. Why? Because as the power is 2, we will say it is not cubic, it is not linear, but it's the quadratic polynomial. So this is the way how to understand the quadratic. Simply, let me ask you, what about a linear one? Linear polynomial? Simply say x plus 2. It's a linear polynomial because the degree will be 1. Like this, by seeing any polynomial, you can understand which type of polynomial it is. First of all, you have to understand whether it is polynomial or not. How to check it? By seeing the power. The power should be of whole numbers. If it is not, then we will say this is not a polynomial. That's it. Now, if it is a polynomial, then what about the degree? Count the highest power. What is the highest power? That will be its degree. If the degree is 1, means the highest power is 1, it's a linear polynomial. If the highest power is 2, it is quadratic polynomial. If the highest power is 3, it is cubic polynomial. If the highest power is 4, it is biquadratic polynomial. If the highest power is 5, we will say it's a 5th degree polynomial. If the highest power is 9, it's a 9th degree polynomial. So this is the way how to categorize and understand the terms, the coefficients, the powers, the exponents and the name of each polynomial. So hope you understood today's session. So this is all about exercise 2.1. So that's it for today. We will get into the next exercise in our next day. Till then, take care and have a good day.